Hello, good day. Today we will be solving this problem together. This simple problem. So it says the set m equals to x such that 2 is lesser than equal to x and x is lesser than equal to 6. And then n is equal to x such that 4 is lesser than equal to x lesser than equal to 8. They are subsets of the universal set hex such that 1 is lesser than equal to x lesser than equal to 10, where x is an integer. We have to find m prime intersection n prime. That's m complement intersection n complement. Now what do? First of all, we have to find the elements of each of the sets first before we can find the intersection. So let's go. We start with m. M is we're given the range, like the range in which x lies. So x is between 2 lesser than equal to x lesser than equal to 6. So now that means, now you see that there is a lesser than equal to sign here. That means this first number is going to be included. It's just like when I say x is lesser than equal to 2. So that means from 2 towards the side of the number line, those are the values. 2, 1, 0, minus 1, on and on like that. That's what it means. You see that 2 is included because of the equal to sign. Alright? But if I'm saying x is lesser than 2, definitely 2 is not going to be there. It's going to be from 1, 0, just like that. So same thing applies here. If 2 is lesser than equal to x, so that means from 2, right? 3, look at it, 2 lesser than equal to x lesser than equal to 6. So 6 is between this range, 2 and 6. Then because of the lesser than equal to sign, you include these values, 3, 4, 5, and 6. Okay, so n now is equal to what? N is equal to x such that 4 is lesser than equal to x lesser than equal to 8. So that means x is between 4 and 8. Is from 4 to 8. That's what it means. So you start counting. You have 4, 5, 6, 7, and then 8. Then we come to the universal set, which says x is from 1 to 10. Alright? So we have 1, 2, 3, 4. Okay, let me clean it and so that I can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just trying to manage the space, so please pardon me for that. Now we're not done. We have to find m prime intersection n prime. That's m complement intersection n complement. So what is m complement? That m complement means the elements in the universal set, alright, that is not in m. It's as simple as that. So m prime now equals to, what are the things in m that are, what are the things in the universal set that are not in m? For instance, 1. 1 is in the universal, but you don't have 1 here, right? 2, no. 3, no. 4, no. 5, no. 6, no. What about 7? Yes, there's 7 in the universal set and you don't have 7 here. So 7 is one of the elements of m complement. What about 8? Yes. What about 9? Yes. And then 10. Okay? So let's go ahead to find n prime as well. Elements in the universal set that are not in n. That's what n prime is. Okay? If you look at it, n is between 4 to 8. So from 1 to 3, that's how to make it faster. From 1 to 3, 1 to 3, you don't have that. So 1, 2, 3, 4, 5, 6, 7, 8. You have that here. 9 and 10. 9, 10. Okay? So now to the final question, which says m prime intersection n prime. It means, when you say intersection, it means what is common to both sets. Alright? So what's common to this, the both of both sets now, the both of m prime and n prime? 1 is common. Okay? Is 7 common? No. 2 is not common. 8 isn't common. 3 isn't common. 9 is common. Okay? And then 10 is also common. So this is our final answer. N prime intersection N prime is equal to 1, 9, 10. So that's our answer. So please follow us. Follow, like, share, comments. If you have any suggestions, you can just put them in the comment section. I'll definitely reply to them. If you have suggestions, if you have recommendations, whatever it is, put them in the comment section. I will reply. So please follow, like, share. And then if you're watching us from YouTube, please subscribe, like as well, follow, share, comment. Thank you very much.